All right, let's talk about TypeScript. You've probably heard it called JavaScript with types, and yeah, that's true. But it's so much more than that. It's a tool that really changes how you write code, acting like this incredible safety net for modern development. So let's see how it actually works. I want you to just imagine this for a second. What if you could catch and fix a huge chunk of your bugs, not when a user finds them, but while you're literally still typing? That's the big promise of TypeScript, and it's what we're going to dig into today. To really understand why TypeScript is such a big deal, you first have to appreciate the nature of plain old JavaScript. Honestly, every time you ship JavaScript code, you're kind of making a bet. You're gambling that all the data flowing through your app is exactly what you think it is. So let's look at a super simple piece of code. We've got a variable called message, and we're just trying to make it lowercase. Looks totally fine, right? We've all written this 1,000 times. But see, here's the gamble. What happens if somewhere deep in your application, that message variable isn't a string? What if it's a number, or it's null, or an object from some API you didn't expect? All of a sudden, that harmless little line of code is basically a ticking time bomb. And boom, at runtime, when a real person is using your app, the whole thing can just crash. You get this classic type error. And the problem is, this doesn't show up while you're coding. It happens when the code is live. And that is absolutely the worst, most expensive time to find a bug. And this is where TypeScript steps in. It acts as the static safety net, specifically designed to catch these kinds of errors before they even have a chance to happen in front of a user. It completely changes the game. Now, the magic behind this safety net is something called a static type system. I know, that sounds a little academic, but the idea is actually really simple. It's just a way for you to describe the shape of your data. You're telling your tools, hey, just so you know, this message variable, it's always supposed to be a string. And the tool uses that info to run a kind of pre-flight check on your code. And this slide really shows you the fundamental shift. With JavaScript, you find out you have a problem when the app crashes at runtime. With TypeScript, you find that exact same problem because there's a red squiggly line under your code, right there in your editor as you're typing. The difference is absolutely night and day. But wait, it gets even better. TypeScript also catches what I like to call silent failures. See, in JavaScript, if you try to access a property on an object that doesn't exist, it doesn't crash your app. It just silently gives you back undefined, which can cause these really sneaky, hard-to-track-down bugs later on. TypeScript sees this and immediately calls you out on it. It knows the shape of your user object, it sees there's no location property, and it tells you right away. This feature alone will save you hours of debugging, trying to figure out where some mysterious undefined value came from. Okay, so TypeScript is obviously a fantastic bug catcher, but that same information that it uses to find bugs, it also unlocks a whole suite of superpowers for you right inside your code editor. For example, it catches those annoying little typos we all make. I mean, look at toLocal lowercase. It's misspelled. JavaScript would just crash at runtime. TypeScript highlights it for you instantly. It also finds these weird logical errors. In this case, the developer completely forgot to call math.random with parentheses, so they're comparing the function itself to a number, which just makes no sense. TypeScript spots that impossible comparison right away. And this one is just brilliant. This shows you how smart it is. Because TypeScript knows the value variable can only be A or B, it understands that in that else block, the value has to be B. So checking for it again is totally pointless. It literally sees unreachable code that our human eyes might just scan right over. And all of this type information is what fuels your editor's tooling. You get incredibly smart autocompletion that knows exactly what methods are available. You get quick fixes that can automatically solve the error for you. You can rename a function across your entire project and be totally confident you didn't break anything. It makes the whole experience just faster and so much smoother. So you're probably wondering, okay, this all sounds great, but browsers don't run TypeScript, they run JavaScript. How does any of this actually work? Well, let's pull back the curtain and see how the magic trick is done. The whole process is handled by a tool called the TypeScript compiler, or TSC for short. It's basically a three-step dance. First, you write your code and a file that ends in .ts. Second, you run the compiler and it checks your code for all those type errors we've been talking about. And third, if everything looks good, it just transforms your .ts file into a clean, normal .js file that any browser on Earth can understand. Now, the way we give TypeScript all these hints is by using what are called type annotations. You can see here, we just use a colon after our function arguments to say what type they should be. We're just telling TypeScript, hey, person needs to be a string and date has to be a date object. It's that simple. But here's the really cool part. What happens after the compiler does its job? Poof, the type annotations are just gone. This is a super important concept called type erasure. The types are only there for checking your code, and then they get completely erased to produce standard everyday JavaScript. And this brings us to the most important rule of TypeScript. The types are a development time tool only. They exist to help you, the developer, write better code. They are completely stripped away and have zero impact on how your program actually behaves when it's running in the browser. All right, one last really important thing to know is that TypeScript isn't this all-or-nothing system. You have total control over how strict it is, which makes it incredibly flexible and easy to adopt. Just think of it like a dial. If you're adding TypeScript to a massive existing JavaScript project, you can turn that dial way down and just opt in where you want. But if you're starting a brand new project, you can crank that dial all the way up for maximum safety from day one. Settings like noImplicitAny and strictNullChecks are what really give you the full power. So when you put it all together, catching errors in your editor instead of in production and supercharging your development tools, TypeScript really does provide this powerful safety net for pretty much any JavaScript project. Which I think leaves you with just one question to think about. How many of those late-night, head-banging on the desk debugging sessions could this safety net save you?